Good afternoon, Sir Darrell. Before we start, let us introduce ourselves. I'm Raven James Paitan.
And I'm Vanessa Sultan.
And for today, we will going to talk about gay lusaklo. But first, what is gay lusaklo?
Gay-Lussac's law is a gas law which states that the pressure exerted by a gas of a given mass and kept at a constant volume varies directly with the absolute temperature of the gas. In other words, the pressure exerted by a gas is proportional to the temperature of the gas when the mass is fixed and the volume is constant. This law was formulated by the French chemist Joseph Gay-Lussac in the year 1808. 1808.
Law of gas. When the temperature of a sample of a gas in a rigid container is increased, the pressure of the gas increases as well. The increase in kinetic energy results in the molecules of gas striking the walls of the container with more force, resulting in a greater pressure. The French chemist Joseph Gay-Lussac 1778-1850 discovered the relationship between the pressure of a gas and its absolute temperature.
Gay-Lussac's law implies that the ratio of the initial pressure and temperature is equal to the ratio of the final pressure and temperature for a gas of a fixed mass kept at a constant volume.
Formula: initial pressure, initial temperature equals final pressure, final temperature.
This expression can be derived from the pressure-temperature proportionality for a gas, since pressure proportional to temperature for gases of fixed mass kept at a constant volume.
Initial pressure, initial temperature equals constant. Final pressure, final temperature equals constant. Therefore, initial pressure, initial temperature equals final pressure, final temperature equals constant. Or initial pressure, final temperature equals final pressure, initial temperature.
Example of Gay-Lussac's law can be observed in pressure cookers. When the cooker is heated, the pressure exerted by the steam inside the container increase. The high temperature and pressure inside the container cause the food to cook faster.
Another example, a gas has a pressure of 699.0 mmHg at 40.0 degrees Celsius. What is the temperature at standard pressure?
The gas has been assumed to be an ideal gas from the variation of the ideal gas equation. Initial pressure over final temperature equals final pressure over final temperature. The initial known pressure of gas equals 699 mmHg. The initial temperature of equals 40 degrees Celsius or 313.15 Kelvin at standard pressure. The standard pressure has been 760 mmHg. The temperature at standard pressure can be calculated as
699 over 313.15 equals 760 final temperature. 2.232 equals 760 over final temperature. Final temperature equals 760 over 2.232 Kelvin. Final temperature equals 340.5 0.50 Kelvin. The temperature of the gas at standard pressure has been 340.5 Kelvin. So the final temperature is 340.5 Kelvin or 67.0 degrees Celsius. And that's the end of our reporting.
thank you for listening.